Hello, welcome to your week 13 quiz help video. I will again be trying to give you hints without completely giving away the correct answer. I'm going to skip right to question 3. The first two are true and false. Okay, so what is a functional group here? Well, the only atom that isn't carbon or hydrogen is nitrogen. So that, based on the functional groups we've seen in this class, that would narrow it down to either an amine or an amide. To be an amide, the nitrogen would have to be somewhere near a carbon that had an oxygen on it, but there's no oxygen anywhere around here. And also, you figure out whether it's primary or secondary or tertiary, the same way you do for a carbon or an alcohol. You just count how many carbons are attached to the nitrogen. So here's 1, 2, so that would be a secondary nitrogen there. All right. This is a kind of important topic that was stressed a little bit in the slides. The thing is, you probably want a drug to be soluble, and your blood is an aqueous solution with water, and things that are soluble in water are either polar or have charges. So we want to give the amine group a positive charge. The way to do this is to add, give it. Oh my God. Okay, so we want to add a hydrogen with a plus charge. We'll add an H plus. What is the definition of an acid but something that gives H plus? So we're definitely going to want to add acid, and so remember, when we add a hydrogen to ammonia is NH3, we get ammonium, and that has a plus charge. So if we were to replace one or two of these hydrogens with carbon-based groups or alkyl groups, this might become alkyl ammonia or an alkyl ammonium group. Okay. Amines have nitrogen. Nitrogen have electron pairs that will bond to H plus and remove H plus from solution. What does that sound like to you, an acid or a base, if there's less H plus, less hydronium? The sodium salt of a long-chain fatty acid. Okay, so the fatty acid would have a carboxylic acid group, and that might be in its base form, which we'd call a carboxylate group, and it would have a negative charge. And then that would be paired with a positive sodium ion, and that might be recognizable to you as something that is, that has charge, so it's water soluble. It could form a micelle. It could help you carry oil away. I'm trying to give hints without totally giving it away. It might be useful for cleaning. Okay. A triglyceride might be a fat or an oil. If you add base and heat, that's exactly the recipe to make the same thing we were talking about above here. True and false. And yeah, we were just talking about how you want to make drugs, put them in their soluble form, and the way to do that is to give them a positive charge, and the way to do that is to add an acid, such as hydrochloric acid. Okay, so when you think condensation reaction, it is like, condensation like rain, right? It's going to create a molecule of water. So that's not always true. It could be another molecule that's formed sometimes when two molecules come together. But usually in a condensation reaction, two molecules come together and form water. I'm going to let you guys handle that one. A big theme is soap here. Which of the following is a good choice to add to triglyceride? Remember, the carboxylate is the base form of a carboxylic acid. So if a carboxylate is a base, you'd want to probably add a base rather than an acid. Let's look at the first one. Is that an acid? Yes, that's hydrochloric acid. The second one looks very similar, but you want to find the base here. Okay, let's look at these possible answers. Which is true of a micelle? A micelle, it traps dirt or oil in the middle, and the reason it works is because it makes that oil, which is not usually soluble in water, it makes it soluble in water, so it rinses down your sink. And the main rule about solubility is that like dissolve like. So polar substances dissolve in other polar substances. Does it make sense that non-polar part of soap molecules is going to be attracted to water and want to dissolve in water? No, that doesn't make sense, because water is polar, so it's not going to be very attracted to non-polar things. And the whole deal about a micelle is it takes a lot of soap molecules to surround a bit of oil. A lot of soap molecules work together to dissolve a little bit of oil. And one year we made soap from bacon grease, and people were saying like, "Wow, it's weird to wash your hands in bacon grease." But the thing is, it's not bacon grease anymore. The triglycerides that you started with in the bacon grease, they get chemically reacted to soap. The salt of a long-chain fatty acid. So you might make soap from a triglyceride, but soap is not actually a triglyceride. You guys can handle this one. You guys can handle this one. Glycerin is another name for this. But there's enough in the slides on that one. All right, let me know if you have questions or any more questions on these guys. I think I probably gave you a little too much information already. See how you do.